Hi, so for this video we're just going to do some examples of solving log and exponential equations. It's just a kind of mix of all the different stuff we've had so far using the log rules, using E, changing between logs and exponentials. Right, so for our first question, we have solve for x, and then it's e to the x equals 5. So for this one, we know we've got e to the x equals 5. E is our base, and x is our exponent. So our x is what we're trying to find. And as I said, e is our base, so it becomes our base here. And then we also get that 5. And that is just a case of plugging it into our calculator. Instead, there's not like a log to the e button. This is where I was talking about there's that button that's ln that you press, and then just 5. And then equals, and you're going to get 1.609437, etc. And you round that to probably 1.61 to 2 decimal places. Okay? I would say, just in general, if the question doesn't tell you, do 2 decimal places. Right. So, for question 2, right, I have in fact copied this down wrong. It's not, it should be equals x, it should be equals 3. Right. That's not a problem. So we're going to get log to the base x of 4,913, equals 3. Right, so when we're doing this, our base becomes our base. Like, so if we're changing it about, we're going to get x comes there, the 3 comes across, equals 4,913. So then, to get rid of that cubed, we have to do the cubed root, 4,913, and we put that in, and we get that x is equal to 17. Okay, so it's pretty simple, just following through, changing between logs and exponentials for these two questions. Right, so we're going to go on to our third question. Right, so for our third question, we are solving for x, and we've got log to the base 4 of 2x plus 1 minus 3 log to the base 9 of 3 equals 1. Okay, the first place you might think to go would be to convert your 3 log to the base 9 of 3 into log to the base 9 of 27. But that's actually, for this question, it's not the most simple way to do it. You can do it that way, and you will eventually get there, but it's going to take quite a lot of work. Something to think of, 3 is the square root of 9. Okay, so we can, in fact, kind of say log to the base 4 of 2x plus 1 is minus 3 log to the base 9 of 9 to the power of a half, or the square root of 3, which is equal to 1. So then we can take that half at the front. So we get log to the base 4 of 2x plus 1 minus 3 over 2. And then it's log to the base 9 of 9, so that vanishes. So we're good there, equals 1. Okay, so we've only got one log. Perfect, where we're wanting to head. So we're going to get log to the base 4 of 2x plus 1. When we add that 3 halves to the other side, we're going to get that that's going to be 5 over 2. Because 1 is 2 halves, add another 2 halves onto 3 halves, and we get 5 halves. So then we can do a little bit of rearranging. Our base is going to come here, and that becomes our power, and that's going to be equal to 2x plus 1. So we're using our rearranging rules we used in the last questions. Right, so here we've got 4 to the power of 5 over 2. We can do this over at the side. This could theoretically be a non-calculator question, so you need to kind of know what you're doing. This is going to be the square root of 4 to the power of 5. Okay, with these, it doesn't matter if you do the power of 5 first or the square root first. If you've not got a calculator, I don't want to sit doing 4 to the power of 5 without a calculator, and then I'm not going to be able to square root it when I'm done. So the thing to do is to square root 4. So you're going to get 2 to the power of 5, because that works quite nicely. And 2 to the power of 5 is 32. You're not expected to know that, but you can work that out as 2 times 2, which is 4, times that by 2, which is 8, times that by 2, which is 16, and then times that by 2, which gives you your 32, because I've timesed 5 2's together to get my 32. So you're going to get 2x plus 1 is equal to 32. So you're going to get 2x is equal to 31 by taking 1 from both sides. And so you're going to get x is 31 over 2. Okay, it's quite long, and you can do it by kind of changing the 1 into log to the base 9 of 9 and messing around with solving that kind of stuff. But I did do it that way, and it took me a long time. This is the most simple way to do this question, but it's not necessarily the way that you're initially going to see, but you just keep trying and you'll get there. Right, okay, so the last question we're going to do, we've got log to the base 2 of 2x minus 1 plus log to the base 2 of 2x plus 1 equals 3. Right, so we're going to combine our logs on this side, so we get log to the base 2, and then we have 2x minus 1, and we're going to have 2x plus 1. And the other side, the easiest way to do this is going to be to change this into a log with a base. So we're going to have, it would be like 3 log to the base 2 of 2, because that's just 3 times 1. Okay, so we can then, in our next kind of line, we're going to have log to the base 2. This side we're going to still have 2x minus 1. Then we have 2x plus 1. And that's kind of the same as log to the base 2 of 2 cubed. So that's telling us that 2x minus 1, 2x plus 1 times together has got to be equal to 2 cubed. So that's where we can go from there. So 2x minus 1 times by 2x plus 1, and that's equal to 2 cubed. So from here, this is solving a quadratic equation. Okay, so we multiply out, so we're going to get 4x squared minus 2x plus 2x, they cancel out, minus 1, difference of 2 squares. And then it's going to be equal to 2 cubed, which is 2 times 2, which is 4, times 2, which is 8. So when we kind of sort this out equal to 0, we're going to get 4x squared minus 9. It's very nice, equals 0, they're giving us another difference of 2 squared, which is quite good. So we're going to have 2x plus 3, 2x minus 3 equals 0. Okay, so we're going to have either 2x plus 3 equals 0 or 2x minus 3 equals 0. So that gives us x is negative 3 over 2 or x is 3 over 2. And if we kind of think about this graph, does it make any sense at all for this graph to have a negative value? Okay, so because it's logarithms, we know that our x value for a log graph, if we look at it, a log graph doesn't exist in the negative. So we know it can't be that one, and so our x has to be the 3 over 2 for this case, okay? Because that's for any log graph, it doesn't exist in the negative x. Okay, right, so we're going to go and we're going to move on. That's going to be us for those, and we're going to go on to some of the more wordy questions. Hopefully this has been helpful.